Well, hi there. Thanks for showing up for your learning. We're going to go through all the problem types in the practice test, type by type, to consolidate your learning before the test. So let's take a look here. Our first problem type is to be able to identify the form that a quadratic is in. So here we have f of x is minus 2 times x minus 1 times x plus 3, and I recognize that f of x is in factored form. Factored form always looks like this: the stretch factor multiplied by x minus the first root multiplied by x minus the second root. So we write that way. So this is in factored form, so that is the correct multiple choice answer. And the roots are 1, 0, and negative 3, 0. Okay, this one I have to take this number, and notice I have to flip its sign to find the x value of that root, and this one I flip that sign to find the x value of that root. The form tells me that I flip signs. Okay, so if and then I'm going to graph it in a second. Okay, so let's actually graph it right now. Let's go. So first I'm going to come down here. I'm going to shrink so I can see the whole page. I've got my x-axis, my y-axis, and I'm going to write out up here in the corner f of x is equal to negative 2 times x minus 1 times x plus 3. Okay, let's check if I wrote it out correctly. Yeah, negative 2 times x minus 1 times x plus 3. So that is correct. And now I'm going to plot these roots, 1, 0, and negative 3, 0. Let's put them on. So the points 1, 0 and negative 3, 0, we're going to do this one in blue. 1, 0 is here. Okay, that's the point 1, 0. This is 0, 0, but that's not part of our parabola. And the next one is negative 3, 0. So these are the 2 points, the 2 roots that are on our parabola. Just going to get rid of 0, 0 there. And then I know its stretch factor is negative 2, so it opens downwards. I can also see that the vertex should be along here at the line x is minus 1. I'll just take that up there. X is minus 1, this line here. Just write that on. X equals minus 1. Why do I know that that's the axis of symmetry? Because here, this point is negative 3, 0. And this point is 1, 0. And the vertex should be right in the middle of those. The average of minus 3 and 1 is minus 1. And I can see visually that that's 2 from both of those points. I would move 2 this way to go to the axis of symmetry and 2 that way. So now I know x is minus 1 is the location of the vertex. So let's calculate f at minus 1 to find the coordinates of the vertex. So that's a set of instructions that I just wrote there saying substitute minus 1 in for x wherever you see it. Okay, so I put in minus 1 there, and then minus 1 here. So minus 1 plus 3, and then evaluate. So this is equal to negative 2 times negative 2 times, well, that's 2. Okay, so negative 2 times negative 2 times 2 gives us positive 8. So that tells me that f at negative 1 equals 8. Cool. All right, so that's a point, 1, 8. Negative 1, 8, sorry. So that's on the axis of symmetry, and it's up there at 1, 2, 3, 4, 5, 6, 7, 8. Count it with me, and there it is. And then I could use step pattern from there. So my step pattern is usually 1, 3, 5. But here I multiply all those steps by minus 2. So instead of my step pattern being 1, 3, 5, if I multiply that by negative 2, then my step pattern is negative 2, negative 6, negative 10. So let's try that from the vertex. I go over 1 and down 1. That's negative 2. Over 1 and down 1 the other way. That's symmetrical. Over 1 and down 6. We already had that. That was a root. Over 1 and down 6. That was a root. And then the next ones are 10 down. So I could put that one on too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice that these steps happen between points, not each time from the vertex. And then symmetrical, that would be over here. Oops, sorry, no, it's not. It's right there. Okay, so that one is not one of our points. All right, now I'm going to zoom out so I can draw a beautiful curve through all of these points. Whee! Give me points for trying, okay? I'm trying really hard to make a beautiful curve. It's not so beautiful, is it? Okay, there. Put arrows on it to indicate that it keeps going to infinity in both directions, downwards. All right, so that's how we would graph that one quite accurately, really. Now, let's go with the next example. We want to be able to look at g of x over here and recognize that my face is in the way. Put my face over there. You won't have that problem on the test. I hope I'm not in your face during the test. And we're going to work in another color. Call it orange. And we're going to notice that g of x is in the form the stretch factor multiplied by x minus h squared plus k. Okay, so where hk is the vertex. So this is vertex form. So this one's in vertex form. And it has a vertex. Well, this form also tells me that h is a sign flipper. So I want to flip that one sign. So that'll be positive 2 is the h, is the x value of the vertex. And then this one, I just read it for the k value is negative 12. There we go. So 2, negative 12. Why do I write my 2's in two different ways? I don't know why I do that. I want every 2 to have a loop, and it's not happening. So let's graph it. First thing that we're going to do is put the point 2, negative 12 on there. So let's go find that point. Okay, so here we go. We're going to count from the vertex, from the 0, 0 here, and we're going to go over 2 and down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right at the bottom of the page. Wow. And then with this one, we can go straight to step pattern to find the other points. This function was g of x. I think that's going to intersect my function, but it'll just miss. Okay, g of x is equal to 3 multiplied by x minus 2 squared minus 12. Okay, so 3 is my stretch factor. So normally my step pattern is 1, 3, 5. But this parabola will have will multiply all those values by 3. So it will be 3, 9, 15. Okay, so I go over 1 up 3, boop, and then symmetrical around the vertex, boop, and then over 1 up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we found a root. It's right there, boop. And then this one here is symmetrical. Oh, look, the other root is 0, 0. Cool. Okay, and then maybe you don't think it's cool, but you and I are allowed to have different taste, okay? And then we go over 1 and up 15. I happen to know 15 is just off the graph. Yes, you can plot things just off the graph. You just want to know roughly where they are. And then that's symmetrical over there, boop. That was the 15 step, right? Over 1 and going up by plus 15. Okay, so let's just erase that. And now you zoom out. You don't have to zoom because you'll be using paper. And zoom just means like focusing your eyes in different ways. So that's something I don't need to coach you on at this point, unless you go into concussion protocol. Here we go. Draw this one. We start from the vertex and go up 3, up 9, up, and a beautiful curve. It's just so beautiful, Mr. Jennings. No, it's not. I know that I really botched that one, but I'm not doing a better job. Okay, and then up 3, up 9, up 15. And those are graphed to my satisfaction, and I hope yours. If I asked you what are their intersection points, you would say, well, about there and about there. But I ain't going to ask you that question. Not at this level. Okay, bye for now, everyone. That's how you graph parabolas that are in factored form and graph parabolas in vertex form. Any questions? Absolutely send me an email or ask me in class or track me down and ask me this question. Otherwise, thank you for showing up for your learning. See you in the next